Mic on? Hello? Can you hear me? Oh, the mic is. Our mic is back. Sorry about that. It's 11:50. It's time to start our second session. I think we lost people to the break, and hopefully they'll trickle back in. I apologize for advertising sandwiches that weren't present. They've been doing that the last few years, and I missed the memo saying that wasn't happening.
There actually was a very small tray of them.
Pat found them. I'm jealous.
It was not a flavor I like, so there was like two left when I saw it.
Oh well. Next time we'll get them in Montreal. And I should say that speaking as an individual, not as an IAOC member. So thank you for coming back to Friday second session. We are DETNET for those of you who are joining us remote, and we're not here in the first session. This session is going to focus on data plane discussions. One of the most important things we did in the first session was to acknowledge the service to the community that Pat Thaler has done in the last, I don't know how many years, but she is retiring and will no longer be serving as chair after this meeting. We really want to show our appreciation, or we showed our appreciation, and we want to thank her again for contributing to this group and helping to get started, and of course the IETF and its your work here, as well as coordination with IEEE. Thank you again. So. We have a new note well. Friday second session, we've been over this too many times, so we'll just skip right there. We have the same audio streaming and video here, and please join Etherpad. The link is in Jabber at the start of the Jabber session for today, as well as on list. We really appreciate you helping take notes. I'm on Jabber, and I'll look at it as frequently as I can, although sometimes I miss things, so it would be helpful if other people join as well. Blue sheets are going around. Please sign them. I was madly trying to update slides because we have an agenda change. I did manage to get the update on on data tracker in the slide deck, but not here. The change is that, excuse me, is that we're going to aim to do wrap up actually a little earlier and try to really be wrapped up on the data plane discussion by 2, to have then Stuart talk about the advanced VPN, or enhanced, sorry, not advanced, enhanced VPN, which we actually have talked about in this group many times as the TSN over DETNET service. And he has put together a framework that covers both that case as well as other use cases. Our expectation is that will be talked about in the TEAS working group, but we think it's really important for us to be aware of it, and it actually fills one of the gaps we had identified in the slide deck you'll see in a moment. So that will come before that IGP presentation. If we hit the, we still have time after that, we will talk about the IGP presentation. As I mentioned, right now, control plane is out of scope, but if it helps inform what we're doing in our information modeling and our Yang modeling, having that perspective is useful still. So what are we doing here in this session? We really want to focus on making sure that we have Number one, decided on what encapsulations, what do the data plane formats look like that we are going to use for supporting DETNet services. That's the number one piece. Data plane, of course, is larger than that, but that's the piece we wanted to really ensure that we are on rock solid ground by the end of this meeting. Now, there's other parts of the data plane that we are still left to be done, like the queuing discussion that we had this morning, or even the aggregation discussion that was touched on. We're a little bit of where we were. We had alternatives completed in September of 16. We basically had a design team look at a whole slew of different data plane alternatives and try to come up with a recommendation. We had some discussion of those, came up with a recommendation that was captured in the design team individual document, and an adoption of the design team document in March as a working group document. Sorry, that was October. We said that this is sort of the direction of the working group. And we've had some discussions along the way, and we've gone back and forth on some things, and now is the time that we say these are the foundational data plane encapsulations used in DETNet. One of the important things to note is that this is doesn't say that there can't be future enhancements to these data planes or future alternatives. For instance, the beer and doing DETNet over beer TE is something we could consider, but only once we finish the baseline work. And of course, when there's support from the working group, and of course, we have to make sure that the beer working group who owns the data plane is okay with what we're doing. So keep in mind, DETNet is more than just PREF, although PREF has certainly taken or consumed a vast majority of the data plane discussions. It's just one of the DETNet services, and it is only one way of doing service protection. For example, the architecture allows for, it used to allow for, hopefully it still does, allows for alternate service protection mechanisms, and I believe network coding is mentioned as a future possibility. So PREF is just one piece. Certainly we like to focus on it, but we have to keep in mind it is just one way of delivering one of the core services of DETNet. We also have congestion protection and latency control. My personal favorite there is zero congestion loss, but that's a personal favorite. We have explicit routes or route pinning, and what I talked about with already service protection. The core usage scenarios we've been focusing on is TSN over DETNet and IP v4, v6 end-to-end service. We certainly had a time where we said we're going to do v6 first and worry about v4 later, and I think we've received enough discussion in the working group that we really have to look at both cases equally. We can't treat v4 as a second-class citizen. So what are the key questions? Can we reach agreement? Do we have agreement on DETNet over Mpls? What the encapsulation, and that's both for the PREF and non-PREF case. I think we have a good idea of what it looks like, and it's just let's confirm and document it, and then ensure that that is what we're doing. So the next thing is do we have agreement on what the simplified IP approach is? And we expect that to be for both v4 and v6. If we have time, it would be good to agree on approaches for IP over Mpls. There's a couple of different ways of doing it. We can either carry IP sort of the natively over Mpls like you would do in a core instance, or we can do an L3 VPN approach. And we have to talk about that, whether we want to allow for, well, certainly we don't want to preclude anything, but do we want to define both, or do we want to focus on one? We have the queuing discussion that Norm touched on, aggregates that Stuart touched on. Actually, you also hit OAM, and transport protocol impact, which was touched on at the last meeting by Pascal, and we really don't expect to get to that last one. If we get to any of these other topics, for me and for the chairs, that's gravy. As long as we hit number 1 and 2, we'll have accomplished the purpose of the meeting. Is that mic on?
No, maybe the other one.
Thomas, so I'm not quite sure if I should read the current documents with the maybe multicast, we don't know, or yes multicast or no multicast. It would be nice to have a clear yes or no for this first round.
I would assume that the data plane covers multicast. I haven't heard any discussion about unicast only.
Well, okay, but that basically means yes, multicast for the data plane, but I'll have to revisit all the implications of, the multicast group as a destination address, and, whether, that also means point to multipoint in the MPLS side. So
I would expect the answer is yes. I mean, we've always said that we do unicast and multicast, but you're right, we haven't talked at that level, and I'm saying assume. I'm not saying that we have consensus.
Yeah. I think it would be good for this to make an explicit ask, for people to feel confident of explicitly revisiting this. In the case of multicast, I'll try to do it for myself, but if you don't have sufficiently many people coming back, say that they feel sufficient, having reviewed it sufficiently to support multicast, then you may not want to claim it, right?
Right. So I'm not sure I've assumed multicast pref, because I don't know really how to do that. I think it's doable. So I think at making sure that when we get to the end of the discussion of each of these 1 and 2, we should say, does this work for multicast? Are we all on board for multicast? And to be clear, for MPLS, I'm saying point to multipoint. For IP, I'm saying multicast addressing.
Yeah. Again, I think the high-level stuff would really be when we go to the review and have people feel confident, right? Maybe ask the question if you also feel confident about this supporting multicast, and then you make a judgment call of whether it's considered to be included. Because I can think of 1,000 examples, like differential delay for Norm Finn's bounded latency document as another factor that doesn't exist in unicast, and yada yada, right?
Stuart, I think if we get the pref function right, we can probably get multicast for almost free, because it's kind of PR without the EF, having previously had some prefs.
Yeah, and this goes to a side conversation Stuart and I had, and has been mentioned in group before, is while we think normally of the 1+1 case, it actually is a 1+n case, and you may have n+1? 1+n. You may not be receiving 2 packets that you have to eliminate from, but you may have n. And that we certainly have mentioned that, but it doesn't get mentioned a lot. And I suspect Stuart is right that multicast will fall out if we get it right. Oops.
Yeah.
Okay, Mike?
We've spent a lot of time on that issue of multicast and so on in 802.1, and yes, you're right, it just falls out.
That's great. This is really the key points for the kickoff. I had a couple of slides that just reminded people of what IP over TSN is and what we mean by end-to-end IP. I think the other discussions have hit on this a little bit, and we'll get more on this, and so I'm going to skip over that. And we previously did say that we are not going to aim to do end-to-end IP with trying to modify the IP stack. I think Torles really captured the key point earlier in the first session, where he said other groups have tried to modify the stack and put something between the transport protocol and IP, and have all failed, and that the only option there is IP and IP, and we didn't want to go that direction. So this one has been discarded at this point. We have some wrap-up slides, but we're not ready to wrap up. So with that, we'll jump into Balazs's presentation. And I'm not sure how you're breaking things up with Yoni and Norm, whether it makes sense to bring him in.
We'll feel free to comment.
Yes. Okay.
As I expected.
Oops.
That's
I forgot that they were out of order for a little bit, so that means I'm out of order.
Okay, this is just a slide kit in order to have some background for the discussions. And we have added here in this slide kit some background material and some drawings which we think can be helpful during the discussion. So this is how we have constructed with the slides with Norm and Uni. So what we know is that we have two service types. One is when we are doing layer 2 or TSN transport over a .NET domain, or we are doing IP transport over a .NET domain. And we are considering two types of encapsulation, Mpls and IP encapsulation. This is a drawing from the architecture draft, and this is just in order to highlight what .NET functions we have and how we have grouped them. So the first is congestion protection. It is practically the queuing related stuff, and this is where you need flow identification for this function to work properly. Explicit routes, which means practically traffic engineering paths, and again for this you need flow identification. And there were a third group where we have spent a lot of time, and this is about service protection. This is where we have replication, elimination, and in-order delivery function. And this is the functionality which requires the sequence number to be included in the transported packets. And we have three types of .NET nodes defined: edge nodes, relay node, and transit nodes. So that was so far only background. So we have prepared slides for these topics. So let's start with the Mpls .NET encapsulation. We have separated slides for Mpls with pref and without pref. So this is a slide to discuss what if pref is intended to be implemented in the .NET domain, and that means that you need that control word in order to being able to serve the replication and elimination functions. So we have practically two fields added: the .NET control word, which provides a sequence number for packet replication and duplicate elimination purposes, and the .NET service label that identifies the .NET flow within the .NET edge and relay nodes. And what you can see on the right side, this is just something that we have put in the data plane solution as a simplified representation of these encapsulation formats. So that would be the first slide where we might have discussion. Or everybody seems to be happy with that.
So for the for the control word for the sequence number, right? I'm assuming the context is the S label, not the T label.
Yes.
Right. So I think that's a scalability question we'll have to ask ourselves, right? I haven't tried to figure out if there may be need to have the context be defined through the T-label, because that's, if I'm not mistaken, the aggregation, and would result in fewer.
Aggregation will
context.
be a separate topic, so,
Yeah, so Stuart, we need to have an aggregation discussion because
Yeah.
as you gather, we thought.
that
bit
will be a
about it.
separated
Yeah.
discussion.
You've got this for pref. I don't see that the encapsulation looks any different with and without pref, except that except for the sequence number in the control word. Everything else should be identical.
That's the next slide.
That's the next slide.
But it's really important that we must always have a control word there, because there's a whole lot of work we're doing in PWE3 to retrofit the fact that we shipped a load of Ethernets without the control word, and it causes us problems.
So keep in mind that this is the generic MPLS encapsulation. So this applies both to Ethernet and IP. I'm not saying it doesn't counter your point about if we always want control word or not. We still may always want control word, but this is equally applicable for an L2 VPN as it is for IP over MPLS in any of its usage contexts.
Let's do it again. For Ethernet, I think it's absolute given that we have to have the control word there, even if it's just a bunch of zeros, right?
Actually, can we finish on the previous slide before we jump into this slide?
All right, I beg your pardon. All right.
So
Maybe just to finishing my point, right? I'm not the expert on the MPLS side enough, right? But I think it would be good to figure out what's the, best flexibilities we have to define or assume context for the control word, right? So if it's just the fix the S label, that's probably the most simple definition, but I'm just, worried about the scalability of the number of control word flows we can support, because yeah, I mean, well, it's fairly heavy state, right, in terms of trying to keep memory for the sequence numbers you've received in the last reasonable window of packets. So they're I think a lot more expensive than, let's say, the per flow QoS thing we may want to have for the bounded latency. So we want to be careful of if we have anything that could make it, for aggregates. Like we've been thinking of the 28 bits as something that is fairly large enough for aggregates, right? For all the traffic from, let's say, one ingress node to one egress node. And so, yeah, if the context of these could be defined more flexibly so that we can support them on aggregates, that would help us a lot with optimizing hardware resources.
Andy Malice, just in response to Tullis's point about scalability, the scalability is exactly the same as both for pseudowires and for layer 3 VPNs. And I would like to, just point out that we have extensive experience in the field that the routers work fine with the in terms of scalability with the current definition of that label.
So I'm not aware of implementations in L3 VPN equipment where the sequence number is actually used to do per packet deduplication, and that's basically what brings in the state requirements. So any evidence of that to work at the same scale as the well-known large number of L3 VPNs that could be supported, that would be great input, because right now I don't think it exists.
No. So you'll note that there's multiple T levels. So we certainly could, there's nothing that precludes an implementation from adding more labels if it needs more context. And based on the control plane, we'd want to just, or the management plane, you'd want to ensure that it doesn't preclude that.
Yeah,
so
and
it translates to a control plane or management plane.
Right. I'm trying to bring it up from the perspective that, Stuart or other MPLS expert would jump up and saying, yeah, that might be, a change to the control plane to imply that type of semantic, that it would be, that the context would be the T word, or no, you can't do it, even not in the forwarding plane, that semantic,
Yeah,
right?
the existing control planes, I think, are pretty flexible in terms of that.
So yeah, I mean, I think this is the right way to go on. If we end up with, and I think we could hit a scaling limit much earlier than we do in pseudowires. If we do, we'll add a context label, we'll respin the design, but there's nothing fundamental involved.
Right.
But do you think that even with this forwarding plane, the interpretation later on could be that the context or the sequence number is the T label?
No, I think if we look at, well, we're jumping ahead because I'm sure you're going to talk about aggregation. I think we'll do aggregation first, surely. an aggregation will save this, because you can you basically get a new set of labels.
So the one related topic that I expected to come up, and I even have a spreadsheet that I sent around to a few people ready to go, is the number of bits in the control word sufficient for the data rates we're expecting? And so I'm losing my voice apparently. When we did the analysis offline, we identified that there's a spectrum where there's absolutely no issues. And it's only when we started talking about flows at about 400 gig. So this is a flow of 400 gig at 64 byte packets that we started running into issues with the number of bits we have available. And again, that's not a link, that's a flow.
And when we get there, I guess we'll just have a different, slightly different modification on the design, but it'll be a while, won't it?
Right. I think what we'll end up with is an extended control word that, you know, it becomes a 64-bit control word. Norm Finn.
Norm Finn, are we saying we're good with 16 bits?
Can I show, is it all right if I show the slide?
Okay, let me.
No, I have it here.
Let me say, I've got no problem with doing more bits. I think people need to understand what we're using this for. Okay. The implication is that we're using this to eliminate duplicates. Okay. If we're worried, so the implication is that I can remember which, the implication of 16 bits is that I can remember among the last 32K packets that have gone by, which of them I've seen and which of them I haven't seen, so that I can pass the ones that I haven't seen. Okay, so that implies that I've got at least 32 kilobits of memory at 400 gigabits per second, and I can remember, so I can tell which ones I want to pass and which ones I don't pass. Okay, so it's not just sequencing, it's not just the things we've used this before. And yes, it's true that at that very high data rates per flow, I could overflow that number. But keep in mind that anything more than 16 bits assumes that I can remember which of the last 32K packets I've seen. If you want to go to 28 bits, that implies that I can remember exactly which of the last 2 to the 27th packets I have seen and I haven't seen. Okay? My opinion is that that's absurd. Okay? That I'm not going to do that in any foreseeable future. Okay? Now, I don't have, in spite of that, I'm not going to object if people say they want to have more bits than that. But it's absolutely essential that we have an option for 16 bits only, because I want to interoperate with existing equipment that has only 16 bits. So I have to know when I go from 2 to the 16th minus 1 to 0, I have to know whether to treat that as a new packet or as something I've already seen. Okay, so every device has to be able to run in 16-bit mode, whatever we do.
All right, so
And that would be also good for the TSN interworking.
So yeah, I think this goes back to a more precise specification of, you know, the behavior of the duplicate elimination, right? Because in my mind, I was assuming something like I would definitely never have more than 16 bits in the bit mask of the, you know, packet numbers I've received, but it might be a sliding window within the 28-bit. So, you know, everybody may have their own assumptions, right? So I haven't tried to figure out if all the things that people typically do when they have larger sequence number, but obviously only a smaller part which is active, how much better that is over saying, well, everything is fine with a 16-bit, and we may get very close to, overrun there, right? So I think that's an important design parameter. But yeah, I mean, I'm not sure how fast we can work out all these details, but yeah, definitely, if we can at least start agreeing that there will be never more than 16-bit, for an elimination function, and whether or not we then still need a larger sequence number, making that relative, or shrinking it to 16-bit, all good questions.
I have to say, I was assuming we did the sliding window approach. And I was assuming the sliding window approach, where the number 16 is an implementation choice.
Right.
And Norm is saying right, so I think we're aligned on that. But no matter what we decide, it's got to be documented.
So Stuart, absolutely agree with all of it. I think what we're headed for here is that the size of the window and the size of the sequence number are parameters that we set up when we establish, well, I would call it a pseudo wire, but whatever we're going to call this, and we really need a name for what this thing is. Is it, is it a DETNet wire?
It's a DCW.
All right, a DCW. When we set up a DCW, at each node along the path that's treating it as a DCW,
Relay
as
nodes.
opposed to a relay node, we need to establish the parameters of that specific instance of DCW. And in the terms of the control wording stuff, we just need to make sure that there's enough space in there for the largest we think we're going to need.
Right, and we think that the space available now is sufficient for everything. I think it's in the yellow band.
Yes, and we'll define a new DCW if we have to.
Okay, Yoni's in queue.
Okay.
All right, you're up.
Yeah, I just wanted to remind so I agree with what said about what Norm said and what Stuart said about the sequence number. So even the current draft, the working group draft actually says that the amount actually used bits is something that needs to be accurate by the control plane. And the current hardware that I'm aware that actually do packet replication elimination, so the .1CB, and which are fixed to a 16-bit a sequence number, they actually are able to remember only a couple of thousand of packets. So they have this sliding window, and they have a history buffer of only a few thousand packets. That's how it works.
Since you brought up .1CB, just to your comment, Oles, there is a specification for the detailed behavior. It is described in .1CB. In 802.1CB.
So 802.1CB has a different definition.
Even code.
I know that one, but that doesn't necessarily have to be ours, right?
Microphone? We have people. So the comment from the floor is that just because 802 has done something doesn't mean that's what we're doing, and that's absolutely correct. And that's why we have to have agreement, make sure our document captures it. And I think, Yoni, you're saying that our document already captures this point. So,
But to an extent.
okay. Okay, thank you.
Okay, can we jump to the no pref case? Okay,
You should have control, yeah?
yep. So, Norm is approaching the mic.
Norm, just on what you just said, Lou, it would be nice if we interoperate well with that one CB. So unless we have a good reason to do something else, I'd like to see us do the same thing.
Stuart, the thing we need to keep in mind, though, is that we're probably going to have to operate this over very large wide area networks for some of the applications, and that's where we need to be careful about.
And inner working functions are really important, but we should figure out what's right for DETNet first, and then that goes to the complexity of the inner working function.
Right.
So Norm's saying right.
I'm saying don't
make
it different just because we can.
I agree with you.
Let's try to have good mic discipline. We definitely have people remote. Yoni, could you hear either Norm or Stuart's comments?
No, but I know what they were saying.
Well, I think what we said was no gratuitous differences, but differences if they are needed.
Right. I think we have agreement on that. Thank you. Great. All right.
Okay, no pref. So that is the next discussion topic. So if we do not have replication and elimination function or in order delivery, then we don't need the sequence number. So the discussion point here is whether to include always a .NET control word or not.
Stuart?
You can get this one.
Yes.
We'll talk about it.
I just want to echo what Stuart said earlier when we first came to the slide. We just finished some work in the PALS working group, which was the result of routers doing the wrong thing as a result of there not being the control word for pseudowires. So we absolutely must contain the control word, even if it's just 32 bits of zeros. 32 bits is cheap, and we get a lot of functionality out of it, and we absolutely need it.
So you'll also need it for your OAM, if we're going to have a standard OAM method. But yeah, we've just been through a whole load of pain. As soon as you launch any of these packets to a non-DETNET part of the world, if you're ever going to go across it, those packets could go anywhere and be completely misordered if you don't have that control word there. So please keep the control word.
Agree.
So that covers the case of Ethernet, a layer 2 VPN, where a control word is currently used pretty much everywhere. There's one case in eVPN where it's not, and it's, I think, agreement from field experience that's a bad idea, and that's what I think you're referring to in PALS of cleaning up. So that's L2 VPN, so that's pretty clear. So that's one case of MPLS without pref. We also have L3 VPN, and one more case after that, but it looks like, Stuart, you want to say something.
Yeah, I think that if ever you want to be in complete control of what happens to your packets, you probably need a sequence, a control word to do isolation. So, but maybe I'm jumping too far ahead.
Well, there are plenty of L3 VPNs that don't run with control word and have good isolation.
And they're subjected to ECMP. So the thing you need to be really careful of is, do you wish to control whether the underlay does ECMP on you or not?
Right, and we do have to recognize there's a lot of bad hardware out there.
Yes, there is a lot of bad hardware out there which makes terrible assumptions about what it can do regarding ECMP. The only way for us to be in control of that situation is by including the control word even for IP.
And that only gives you partial control, because some of them say, if I see some zeros here, then I'm going to assume it's an Ethernet and ECMP way deep into the packet. It's a pretty bad world out there.
Right. Yeah, I think and this is as a contributor, not as a chair, I think we have to be really careful if we start changing how IP over MPLS works in the data plane, that we have to be really conscious of what we're doing and make sure we have really wide buy-in. So if we do decide to go that way, we really have to be talking to the MPLS working group on this.
Yes. Well, I just want to point out that it's really not a change for how you do IP, because this is going to be IP in MPLS over IP, right?
Why?
Right. Okay, just
so IP over
right.
MPLS today is done two different ways. One is in the core instance, which is directly mapped onto a fact. You have a fact that is directly mapped to a label. That's one way. The other way is with L3 VPNs, and there's also no control word there.
But there is an assumption about no one cares about the order of delivery-ish, and people expect the packets to be ECMP'd. So we may be in a different, we probably are in a different world from the established IP VPN and IP over MPLS world.
And this is part of the reason why enhanced VPN is a good topic for teas, by the way, is that's a good wider discussion. And
fix your charter.
Go ahead.
Fix your charter. No, what's this? No, I mean, if I remember correctly, the control word and the 0 bits were also done as, way for workarounding on something that was broken in, the way MPLS was used, right? So I think we have prior evidence that if we do understand problems and, they create more ugliness in what we want to do, then let's bring it on the table. I'm not sure if any of the things that Stuart mentioned would have, reasonable additional workarounds, or else we're saying we don't care about, broken equipment. Let's just document it accordingly, right?
It is true that my memory is there was an IP pseudo-wire defined also, but Stuart and Andy may know better. I'm not sure anyone ever used it or ever implemented it. So I think the main point here is if we really think we need to do something different than what is typically done in the data plane here, we should be careful to coordinate with the folks that own the data plane, which in this case is the MPLS working group. So I think what we heard here is without pref for layer 2 VPN, this is a no-brainer to always include the DETNet control word. Is that correct? Does anyone object to that? Great. With IP, I heard that there is a preference to use the control word from some people. I'm not sure it's clear to get that we have agreement in the room because we didn't get here from all people. So I think it would be good to ask the folks that are here 2 questions of, do we want to use the control word for L3 VPNs and do IP? Yeah, sorry, L3 VPN implies IP. So question 1, do we want to use control word in L3 VPNs? And question 2 is, do we want to use control words when we're not doing L3 VPN? But as I'm saying this, I realize the first question is do we want to support IP over MPLS only via L3 VPNs or both ways that are supported today? So let's have a discussion on what way we think we would prefer to do IP over MPLS.
Okay, so very generic, and maybe this is not a permitted opinion, but whether we do
all opinions are permitted. We may not, it may not be a consensus opinion.
I would always like to have a control word, even if somebody doesn't need the resilience of pref, because I very much like the OEM aspect of it, and so I think that would help a lot.
There are, just to clarify, there are ways to do OEM on MPLS LSPs.
I understand that there are all these type of other wonderful subnet layer specific OEM technologies, and I'm saying that if I want to figure out what can I do with DETNet itself, across all the different possible encapsulation forms, the most simple one coming to mind.
By the way, use your name. I'm asking.
Torles, yes. Yeah. Sorry. Right. So yes, but they all come with a variety of issues, right? And I think the control word is really a very strong, operational feature as well for DETNet itself, and not only for pref.
Well, I'll make one observation there is we're talking about DETNet over MPLS, not DETNet over pseudowires. So we have a control word, that's part of it, but so is MPLS. So if there's a mechanism that we're going to use, it's okay to use MPLS mechanisms. And in fact, particularly when we get to the T level, we're going to have to use those mechanisms.
Right. Okay,
so we shouldn't say that DETNet is only.
No, understood. So I would. That's a good refinement, right? If the underlying mechanism we're using does provide a control word that is equal or better than what we could have in a DETNet specific header, I'm very happy to use that.
Okay.
Stuart, so I guess the right way to think about this is we almost certainly need to have a VPN type approach in the system, because edge PEs, edge nodes may well be handling 2 different clients on 2 different services. We also need to consider that we will probably have to run pref on some of these. So the right way to approach it is probably to define VPN over with the control word in there, and If there are specific cases where we want to simplify that by taking bytes out of the header, then they should sort of stand on their own merits. But we can do everything if we have a VPN label and a control word in there. You know, we're kind of golden as far as I can see. We may ship a bunch of zeros, but we can solve all the cases.
Andy, one other thing I just want to point out is that it makes implementation simpler if we make the header the same in all cases.
Right.
Can I say something?
Please.
Yeah. So
Sorry, if you don't leave the queue, we don't know that you're back in queue.
okay. In my previous life, so the experience was that the less option is better. So echoing what Andy was saying, that please do a unified header construct if it's just possible. So it just makes life easier, even if you're not using it at some point. So that we can work around with some mechanism, control plane or reserving bits or something.
Stuart again, and of course, since you have to configure this, to set it up and expect this is going to go through there, the hardware can just skip all these zeros. It doesn't have to sort of pass them and figure out that they're there. But it just gives us a sort of simple, unified approach.
Okay, so I think I heard that there's a strong preference to always use the same format, meaning always keep the DCW present. I'm going to go out of order in terms of questions, just because it seems to match the flow of the conversation. But if it peters out, maybe we'll go there. We'll go back to it. In terms of support for IP over MPLS, do we want to support an L3 VPN approach or an enhanced L3 VPN approach first?
The mic is out. Try the other one.
Stuart, I think that's what I was trying to propose before, just because if ever we need pref with IP, we will need the sequence number, which means we will need the control word, which means that, and we probably want some context for it. So what I've been saying is, let's always assume VPN, which provides context, control word, which provides context, and then the IP, and we not to optimize away those 8 bits.
Okay, so separate from the control word for a moment.
Yes.
Not talking about control word.
Right.
Do we always want to say we're doing, in order to support the IP over MPLS?
Yes.
Do we always want to use an L3 VPN technique?
That is what I've been suggesting, because I think it makes our life a lot simpler and it makes everything a lot more flexible.
Okay. And I'm actually saying, do we want to do it first? And then I was going to ask only, but that's fine. So you want only, that's good.
Yeah, certainly first, if someone can build a case, this is Stuart still, if someone can build a case for optimizing away those 64 bits, then great. But I think we should start by building the general solution, which will cover most of our applications.
Okay.
Andy, I would also like to point out that without the VPN approach, meaning the S label, the flow identification becomes much more difficult.
Are there any objections with having the initial approach to supporting IP over MPLS be within the context of an L3 VPN? Any objections? I see no hands in the room. That's good. Or that's fine. Is there anyone who would like to see that our initial definition includes native IP over native MPLS, like you would do in a core instance today? So if you're running in a router today and you're an LER and you're not running VPNs, you would just map IP into MPLS. Does anyone want to see that as part of the initial definition of DETNET IP over MPLS? I see no hands. Hopefully it means that people are paying attention, are just not interested in that. So one thing is we're not precluding that in the future. And it does seem like a reasonable initial use case. All right, so I think we have.
Mpls finished. Mpls
I
finished.
think we have Mpls finished. I'm not sure I got all the. You could summarize. Make sure the minutes have a summary of that.
Okay, so the next discussion point is about IP encapsulation. Here we have discussed during the interim the simplified IP approach, and that would be that we are using the application native encapsulation format. So the .NET encapsulation is the unmodified IP stack. And here we can use a 6-step rule in order to identify flows. Of course, we can make wildcard on it. And that means that there will be no sequence number included. So the impact of that there is no sequence number included, that as you can see here on the slide, this upper gray end-to-end pref scenario, this is what is not the case for the simplified IP approach. What we have is the case below, where in each segment, link or subnet, the appropriate mechanism will ensure pref inside that link or subnet. So how the encapsulation looks like. So this is how a simplified IP packet looks like. So we have a payload, and it is in a IP transport header like UDP. We have the IP header, data link, and physical. And we can use the 6-step rule in order to match the flows. And we have this flow identification per hop and the standard router IP header processing at each hop. So we are just touching the TTR and the checksum. If we intend to implement .NET functions with this simplified IP, then for the congestion protection, we need the flow identification, and we can do that with the 6-tuple match. We can have the explicit rules based on the 6-tuple match with some policy-based routing. And we are not supporting the service protection like replication, elimination, and in-order delivery because we have no sequence number. So that would be the scenario.
At the very end.
Maybe it's good to show the next slide just before the
Yeah,
discussion.
just to see history. So this is something that is not updated in the current data plane solution version. So it is out of date from that perspective. So this is still something to be added to that document.
Yeah, I'm pretty sure actually only updated it last night and removed the section.
It was just removed,
Yeah, it was just removed.
this, but not added the simplified IP. So
So he did the red
Zero
X. He
version.
did the red X.
yeah, exactly. The red X is there in the document. Okay.
Okay, as I pointed out in my talk earlier, if we want to do pref, we really do need a sequence number. And my draft provided an encapsulation which allows us to do pref for IP, which still conforms to the simplified model. So I would much prefer that to this.
So maybe we should take it as from the perspective of host first, and then other cases, other places where we would use IP, because you mentioned that host was you weren't proposing it for the host.
That's correct. Okay, I'm cool with that.
Does that work?
Yes.
Stuart, so does this one work? No.
It was changed, yeah, it should.
Stuart, so what we're proposing here is basically ACLs throughout the network directing us to queues and nothing else. Is that where we are?
Do we have the network diagram? Do you have the network diagram?
Yeah, I think we need that for the discussion. So what this means that where the red circles are, this is where you will see the simplified IP encapsulation. Within the segments, which is just now highlighting with that blue tunnels, Inside that, you can have additional encapsulations, you can add sequence number, but your pref function will be limited between that blue stuff. So here in this figure, for example, you have 3 pref domain, and they are operating independently. You cannot do that. You are replicating in the first domain and then eliminating in the second one.
So I'm just trying to make sure that we're all absolutely in sync here. So this is the case where basically we're not doing anything different from what we do today. We're doing an ACL used to map the packet into a queue at each hop where we care, and the packets go as regular IP. So this is just unmodified IP with a bit of ACL mapping to queues.
Except now we're mapping into DETNET, and I'm not sure if you want to call it ACL or PBR, but either way, it's a rule in the router.
You need to be on this one. It doesn't work.
Yoni is in queue before you, Norm.
Yeah, so I want to point out, so we did discuss this interim tree quite extensively, the same situation. So assume, for example, a deployment where you have TSN, Ethernet TSN in segment 1 and segment 3, and then you have the DETNET Mpls encapsulation in segment 2. So within each segment and between the segments, you have a router. So you are doing a routing between segments, but within each network segment, as Palas said, you can do all the service protection things until to a point when you reach the routing hop, for example, that is between the segments, and that place is somewhat non-trivial in the sense that because each of the segments are independent, more or less. So if basically it usually in a simple deployment it ends up to a case that you have a single point that you go from between segments. If there's like a replication taking place in segment 1 and segment 2, because those replication eliminations are separate. They don't share any state in between each other. So it's a bit more than just ACLs. So,
Andy, I would like to ask that we separate the discussion of what's in the red circles at the endpoints and what's in the red circles of the network, because I'd like to argue that those are not necessarily the same.
I agree.
And in fact, that's exactly what the proposal is that the endpoint would be limited to the subnetwork alone.
Yes.
Which we're saying is for it.
Right.
For example, TSN. In the other places, you might have a technology like IP over MPLS,
Yes.
right, like we just described, or IP over MPLS over IP. That's also.
Yes. So yeah, I would have been happier if those circles had been different colors, because all 4 circles are red, someone could get the impression that they're all the exact same encapsulation.
Okay.
Right. And the same treatment. And someone could get the impression just by looking at that diagram, as it is now, that all 4 circles get the same encapsulation and the exact same treatment. And that's not necessarily the case.
So at one level, they do get the same treatment. At another level, they don't.
That's right.
So it's at the IP layer, they're getting the same treatment. At the subnet layer, they're getting different treatment.
Absolutely, yes. So I just want to make sure that we're all on the same page with respect to this diagram. Okay, thanks.
Thomas, yeah, so I'm still trying to understand the 6-tuple. We already were chatting about that in before. And I've got this phantom pain of, 10-year-old technologies were trying to use DSCP for something that they weren't.
Can you lean in a little? I'm having trouble hearing you.
Okay, yeah. I got, the phantom pain from old technologies. We're trying to use DSCPs to indicate, different paths through the network and other things that they weren't meant to be used for. So I'm a little bit trying to understand what would be an example of having, the same 5-tuple, only different in the DSCP field, to do different things in DETNET, to map that are. Well, I mean, if it's just
Also
the
keep in mind
per
that
hop
could
behavior-
be, it's not necessarily one value mapping, you could have a few DSCP values mapping to a single flow.
No, that is fine, but that basically would be, in my case, a 5-tuple match. And then you basically have the intraflow QS behavior, which is how we define it in our QS architecture, right? PHBs can, as an AF, can have multiple DSCP, but that
You
doesn't
mean the
mean
diff serve architecture? Do you mean the diff serve architecture?
Well, yeah, I mean, if you look at AF, right, where packets are having AF 41, 42, 43, and so on, right, it's one flow, right, but it's basically, the PHB is defined through different DSCP classes. That's fine, right, but that is not a 6-tuple classification to me. The flow is classified by 5 tuples, and then, yeah, sure, you can use multiple DSCPs. But so what is your idea of a 6-tuple classification? As I said, right, is there any example where we have the same 5-tuple, 2 different DSCPs, and they're matched to, I don't know, different flows?
Isn't that how diff serve does it today?
No?
No, for
Why?
example,
You can use different classes. You can use EF and AF on the same flow just fine.
Yes, of course, but
And they're going to receive very different treatment in the network.
but that's one flow. That's 5-tuple classification.
That's right. So we're not talking about what a diff serve flow is. We're talking about a DETNET flow.
Right. And a DETNET flow can have multiple DSCPs, but the flow is identified by 5 tuples.
Do you want different treatment based on the DSCP values?
Of course. That's intraflow. That's not interflow. If I'm
Right.
saying
So
I'm
I
identifying...
think we're arguing semantics. From a DETNET level, those would be different
Right.
DETNET flows.
Yes. And then I think the DETNET flow is identified by a 5-tuple. And of course, inside the DETNET flow, there's DSCP. And DSCP is treated as we've always done it, or we define new DSCP treatments.
In the absence, okay, let me put it this way. I don't know what to do with a DETNET flow that with different priority levels in a single flow, because I don't know how to guarantee end-to-end latency. Now, there's nothing wrong with having different code points. Now, in 802, we do have that situation where you have a layer 2 priority, which is different on different packets. And the rule that we use there is that it has to have the flow ID and it has to have the right priority, or in this case, DSCP, in order to get the DETNET bounded latency, zero congestion loss service. If you have a packet in a flow that has the wrong DSCP, I would expect it to not get the same treatment, the same queuing, the same QoS that the other stuff has. And so that's not a problem, I don't think.
maybe just one more comment is that in the flow information model, you have a flow rank. And this is exactly what you can encode in DSCP, for example.
Give me any example. So let's say we're saying what I think is correct is we're classifying flows by the 5-tuple, and each of these fields in the 5-tuple can of course be, wildcard. What do you think we can't do, right? Inside the flow, we can use all the DSCPs as we want to define. Sure, if we want to have determinants.
But if we don't include DSCP in the DETNET flow definition, they will all receive the same DETNET service independent of DSCP. So if you want to have different service from DETNET.
But that's not the flow classification. That's a different.
That's DETNET flow classification. Yes. We're not trying to use don't use the DSCP flow and subflow definition. This is the DETNET flow definition. So if you want, you can think of it as how do you map DSCP aware flows to DETNET flows, or to the DETNET service. So we're saying, maybe this is a better way to phrase it for you, is that these map to different DETNET services. Does that help?
Different QoS.
No, I think, this is Stuart, I think the right way to address this is to start with what the application is. I mean, normally what you do is you classify a flow according to the 5-tuple and then map it to a service level using DSCP. It may be legitimate to have different DSCP values within a flow. That's absolutely great, but I think we need to start by understanding why you'd want to do it. And then I think the whole thing will just fall out and we'll all understand what we're doing.
So start from the application point.
Pascal, did you want to, I think you're in queue?
Yes, I was just pointing out that maybe the application flow is the 5-tuple, but the DETNET flow, the thing that DETNET cares about inside that flow is the 6-tuple. So it might be that I'm sending video with some ads on it. Maybe the ads fly through the normal internet, but the video flies through the DETNET path. Well, okay. So that's in my dream world. The point is, I'm surprised that you're surprised because it's normal that DETNET filters out what goes through the DETNET pipe, and maybe we have multiple DETNET pipes. DETNET doesn't care about the overall application flow, just about the piece that it needs to treat, which can be a subset of the overall application flow, and it will extract that based on the DSCP and put it on the right pipe, and that's it. I mean, I don't see why you're surprised.
Okay, so it's really to me the example that, I'm defining my DETNET stuff. I have one and the same 5-tuple. I'm saying, okay, this DSCP you map to this DETNET flow goes across one part of the network. The other DSCP in the same 5-tuple goes another path, right? That's what I'm worried about. I think it's a bad idea, but I think just get TSV review, get TSV review on this, right? They're not only responsible for congestion control, but also for the QS architecture.
Yeah, so it may be that it's not that it uses a different path, it's that it has a different reliability on it. So you might have one, for example, use pref and the other one not.
Yes, but the whole point is right now, the model that you have allows everything to be applied to it that would be possible to apply to different flows for the other 5-tuples, right? So for example,
and we're building a toolbox, and if someone wants to use a toolbox,
as I said, right? I have some strong opinion because of QS routing in the past, right? I think that's a bad idea, but don't worry about me. Just let's have a TSV review on this, and then I think they'll tell you what the constraints are you should follow.
Maybe just one addition is that an application always have some regular traffic and the DETNET traffic. They might have regular traffic, the applications.
Right, but
Which are using the same 5-tuple.
how likely are they going to use the same 5-tuple?
No, of course not.
Exactly. Yeah. So this is Stuart. So I agree with Toulouse about we need to go and talk to our transport area colleagues. That's the first thing. And the second thing is I think we absolutely have to have that discussion with them in the context of a real example that crystallizes it so that we know this is not a sort of theoretical thing that we might do. It is very unusual to have different classes within the same 5-tuple in existing applications.
And please count on my help to bring up the most horrible examples of what we could do with the current definition. Look, I'm sure that you're thinking also of good examples, right? Which I think would all work with the 5-tuple definition. I'm saying that I'm worried about the really bad things you can do with the 6-tuple definition.
So if we make it 5-tuple, to me that means we ignore DSCP. So
Yes.
DSCP has no influence on selection of a DETNET service. Is that what you're saying?
No.
So what
no,
can you clarify then, please?
Well, I think we've always had the model where you have, insert flows, but then, for example, as an AF, you had basically within the flow different code points, right? That's your per hop behavior. If you look, for example, in the AF class. Right?
So if I have a DETNET flow, which is defined by a 5-tuple, do I provide any different DETNET service based on DSCP?
Yeah, of course. I mean, you have to have some understanding how you define for the service the expected, per hop behavior, right? And that's basically
the per hop behavior is defined by the DETNET service. So we have a
sure,
DETNET
but you need
service.
but you need to express it typically through the DSCP, right? I mean,
no, we're just expressing it here based on the flow ID. Whatever our flow ID is tells us what service we're going to get.
Right, but it seems like you also want to be able within a flow to have. You don't want to have any relative behavior between different packets, right? That's what AF gives you, for example. That means you need to have a per packet marking within a flow, right? Now, if you're basically saying that all packets in a flow are always treated equally, then of course you don't need code points in the flow. But the pure fact that you're trying to do this without relying on the existing architecture for the code point marking would be another good question to TSV.
Actually, that's exactly the question we're debating is whether it should or not. I'm not sure I understood, Torlis, what point you're making, but
It seems much simpler to me that we seem to be getting wrapped around the axle. We're not trying to change how DSCP and how the meanings of the 5-tuple or the meanings of DSCP. We don't route based, we route based on the 5-tuple. When it comes to assigning a given packet and deciding how I'm going to treat it in terms of class of service, not where I route it, but how I'm going to treat it in terms of class of service, we have today the option of people look at the 5-tuple and assign it, change the DSCP. People look at the 5-tuple and treat it as something else other than DSCP says now. We don't need to change that. Included in the definition of what it means if we're doing per flow class of service, and we don't always need to know the flow when we're doing the class of service stuff. When we're doing the queuing, we don't always have to distinguish one flow from another. Sometimes DSCP is all we need to know, and we just defend at the edges of the network, making sure we don't get bogus traffic in a DSCP that'll get polluted if we have excess traffic in it.
Right. Just keep
we're doing
in mind,
things just fine.
If we don't have DSCP and something as we consider as part of a DETNet service, we can't use DSCP to trigger.
Correct.
Which
is why I think we have to allow DSCP to be used in identifying the flow, but many people won't need to do that.
I think that's absolutely correct, but I don't think that's what you said. I agree with 100%. I don't think that's what Torlis was saying.
No, but I mean, Norm was also saying something that I don't see in evidence here, which is, for example, that you're routing on the 5-tuple. There's nothing that basically would limit. No, I mean, if you basically want to...
So we select paths, DETNet selects paths based on a DETNet service.
And the DETNet service is 6-tuple, right?
Right, any of which that can be wildcarded. Anything in there can be wildcarded. In the path selection part of DETNet. How does it decide which traffic to map to a path? Based on the DETNet flow ID.
So quickly, do you think you want to have support within a single DETNet flow of packets having different DSCPs?
What I think this says is that we can identify a DETNet service, so independently provide different service levels, different QoS, different delays, different protection levels. We can do that based on any of these fields.
I understand that, but that wasn't my question.
What's that?
That was not my question.
I think I answered your question.
No.
Ask your question.
No, you're saying I can map a flow to any individual service. I understand that. I'm saying, do you think we need within a single DETNet service support for multiple DSCPs? I know Norm doesn't.
I'm saying we allow it.
Okay.
Torlis, from a toolbox perspective, I think this says it's allowed. From a toolbox perspective.
Yes.
Whether or not I'm going to actually use it or not, that's a different story.
For example, I can imagine limiting the rate of the full frames on a video, and the full frames on the video take a DETNet path through the network to make absolutely sure that they get there, and the other frames take some other path through the network, which is not guaranteed DETNet service. Sure.
Yeah, I would phrase it as I think different DSCPs, I might give different probability of delivery.
Yes. For example.
Right. Torlis, that's a real case.
Okay, any more comments to the simplified IP?
Stuart, so I've been trying to build a mental model of why you would want to do this. So let's see if if I test this, whether my model's correct. If you have an application, and as far as the application is concerned, the 5-tuple just really defines a tunnel to get it from one part of the application to the other. And within that application, you have packets of different priorities and different characteristics needed. Then you distinguish between them using the DISO code point rather than the standard method, which would be to set up a different UDP port or something or other and run 2 parallel sessions. So is that model the right model? Because I kind of need a mental model to understand why we're doing this, because it's not standard behavior. And I'm fine with
I
this
think we
doing
have the
it.
standard behavior in different AF classes.
Sorry?
We have different AF code points, right?
You have different AF code points. You don't normally have them for the same 5-tuple. Normally, you take the 5-tuple and then map them to a diffserv class, rather than try and distinguish within the 5-tuple. And I'm just trying to understand why we would want to do that. What would cause us to set a different code point? And the only thing I can think of is that this is a really legacy application that wants to run on foo, and we're actually substituting UDP/IP instead of foo, and the application has different service characteristics, and we're using the diffserv code point to map between the two, rather than the traditional thing, which would be to put the two of them on a different port and hence have a different 5-tuple. Or maybe I'm wrong. Maybe there's something else, but I just want a model.
Let's turn it around.
Yes.
And Torlis, do you think that there's being more in the TSV area? I'm looking to you to help us out. Is there ever a case where you think that it would be normal for an application to use the same flow, 5-tuple, but to mark some traffic with one DSCP and mark other traffic with another DSCP?
And if so, why? Just so that I can get my model straight.
So I haven't followed the late stuff, right? I had a draft 5 or 6 years earlier up where we're doing exactly describing the benefits of that. But, you know, the details of the QoS weren't really matching up. That's simply exactly the differentiated drop priorities, which AF has, but then you look at the details of how it works. So yeah, I mean, you have the iframes, you want to have them through all the time, and you can do a very nice, I mean, it's all non-deterministic, right? Which is why, as I said, you know, if Norm tells me you don't need this with deterministic behavior, I couldn't refute that, right? But yeah, I mean, the different priorities, right? IPB, so.
Yeah. So that's sort of exactly the case that this, I think, is aimed at.
Yeah, no, and I'm mostly worried about the definition part, right? I was always expecting that we can have multiple DSCPs in a flow, but I didn't consider exactly because of this reason, I didn't consider the DSCP to be part of the flow definition, right? I was always considering that if an application has a 5-tuple, all the DSCPs are always part of that 5-tuple. That's kind of the application level flow. Of course, when you're saying, oh, we don't care about application level flows, we just map, you know, whatever we want to DETNET level flows, that's a fine toolbox stuff. I agree with you on that. I'm just not sure what toolboxes, you know, the IETF would like us to do, right? I mean, there are toolboxes that make it very easy to shoot you in the feet, and that's typically what the owners of those areas or so may want to put constraints on. But I don't know the current policy, which is, as I said, let's take it offline, talk with the TSV chairs. I'll send the email and put you on so that we can have that quickly resolved.
So right now, we are delivering service on a DETNET flow basis. So if we wanted to do things like give different drop probability to different packets within the same 5-tuple, we would have to call it a different flow. And I suspect if we called it a subflow, that would work better for you.
Okay. Can you go back to the slide that had this? No, but yeah, that as well. But no, I wasn't even sure that it meant this is a one-to-one mapping, right? I was expecting that you could map all these different DSCPs or all the DSCP with the star to one DETNET flow.
You could do that also.
Right.
That's
and then
we're certainly not saying to preclude
right.
that.
And then that of course is fine, right? I'm
Right.
just saying that it would equally be fine to say you must always have all DSCPs of a 5-tuple within one DETNET flow. And that seemed to not be acceptable here. I'm not sure why, but
I thought you said it wasn't acceptable, but
no, I was just saying I only need to distinguish the DETNET flow by a 5-tuple, and then it's basically, you know, a service class definition of the DETNET flow. Let's say I'm ignoring the DSCP because the application sent me shit and I'm going to, you know, do one service, or I'm treating it exactly as the DSCPs are to be treated according to RFC standards, right? If it's AF in there, right, and obviously, oh, you must do the right DSCP to get deterministic. I mean, that sounds like logical to me, right? It's a different order. It's not. Right, it's part of the service.
So one
property.
reason we have to consider this now is what we do now, what we're doing right now, we want to make it so it's not incompatible with things that come down the pike. So if we said we're going to only use the 5-tuple and ignore DSCP, it would preclude a DETNET service that was DSCP aware.
No, I don't think so.
It would, because hardware would be built that ignores it.
Why?
Because that's what will happen. Because if we say you're going to only do flow classification on these 5, it won't look at those bits. So we could say those bits have to be 0. And that in the future, we may allow a DSCP-aware DetNet service that does something different, and we'll figure out what that is down the road. So either we ignore the bits, we say the bits have to be set to a specific pattern to allow for the future, or we allow arbitrary bits in the mapping. That's really what it comes down to. And I think it would be good to get a sense of the room, which of those we want to go down. I think the reaction you were getting in terms of just doing 5 is that breaks diffserv, the ability to use diffserv code points ever in the future.
No,
And that we don't think that's, I think people,
I think, when you want to emulate something, let's say like a DetNet service with the AF class, right? Whether or not that would be a good deterministic example, right? And you have AF41 and AF42, right? And obviously these have different drop priorities, right? They're in one queue and they have different drop priority, right? That's what you want to model. So now let's say that, how would you express this in the current model? Are these 2 flows? Is this 1 flow?
for DetNet, it would be 2 flows. And then we would expect in the control plane to somehow associate it to that they share bandwidth, just like we do bandwidth sharing in other cases.
Okay, I mean, so far we thought this is fully, just a forwarding plane thing, and now you're outsourcing the problem to
we're supposed to be coming up with control plane requirements.
No, but I think saying architecturally, we had this all working in the forwarding plane, and now you're saying I can just only reconstruct this when I'm having the control planes stitching together. I'm not saying it's wrong, right?
We can't do any of this without a management plane or control plane. That's why we're doing a Yang model.
No, but I think if you would.
So if we want to do that's one solution.
No,
is that the solution we want? I have
no. I'm trying to get to the point that so I could basically say that I can ignore in the forwarding plane the DSCPs if I, as a separate lookup. If I think, as you're saying, I'm doing 2 6-tuple lookups, and then I'm basically having in the forwarding model the thing. Okay, so this one flow needs to be treated like AF41, the other like AF42, right? Even though you're not doing the DSCP lookup separately, right? So I think that's the difference in the model, right? I was thinking of doing a 5-tuple lookup, and then basically, once you have the flow, the details of the DSCP code point lookup are the same, unchanged as they're today. And you're saying, I think that we're just doing the lookup of the full 6-tuple in this example, and so at this point in time, we don't need to know about the packet DSCP anymore, but we're expecting the same PHB based on. So yeah, I guess that's kind of the modeling question, and I guess that would get back to, again, I'm not the expert. I'm just I was a victim, right? Of TSV.
By saying 6-tuple, we think we can support basically any mode that TSV wants or the applications want.
Well, at least this is a good explanation of the good things you think you can do with it, and I completely agree that we want to do these good things, right? I'm worried about the fact that you can also do the bad things, like
So the question, I think it's a good question for the working group, is do we say we want to do this now, the 6-tuple, include 6-tuple as the definition, or do we say we're only going to do 5-tuple and we have to we ignore the value in the DSCP, or that it has to have a specific value so that we allow for use in the future?
No, and I don't think we can take the decision today. We need to write this down. Sorry.
Well, we can get the sense of the room. So the plan is we're going to get the sense of the room on these topics, and then write something down, and then do the normal review that you would do.
Right, but wait a second.
I think you have someone else, a couple of other people who haven't spoken, so let's give them a.
There's early TSV review, right? We don't have to wait.
No, we're talking about review of the draft, like the next version, not when the work.
No, but that's what I meant, right? If you have TSV questions you don't feel comfortable about waiting for the ISG review, they offer you TSV review at any point in time to clear these questions.
I would do it way before last call. Stuart, you have 2 people behind you that have not spoken. Let's hear from them.
Hi, Fabian Schneider, NEC. Just a quick comment. I don't want to derail the conversation here, but I think I saw some implementations where actually a forwarding element is only looking at the DSCP value maybe at the beginning of the flow, and then for caching and performance purposes looks up only the 5-tuple and then forward it into a queue. So mandating a DSCP lookup for every packet might be very hard for general adoption on every forwarding element. So you might want to consider that.
That's useful feedback. Thank you.
So Kiran, I just want to say, if we do 5-tuple match, then how will we classify a DETNET service when the packet is coming in?
How do we
Just
classify
one.
what?
A DETNET service, how do we say this flow belongs to a DETNET service?
We would do it on the 5-tuple and independent of the DSCP. Does that answer the question?
Depends on the queuing method. You don't need.
Maybe I don't understand the question.
Go on.
Norm Finn, there are different ways to provide the DETNET service. Different queuing technologies. On many of the queuing technologies, you don't have to identify the individual flow. The DSCP is fine. You defend the edges of the network to make sure that the only packets with the correct DSCP, with the with the DETNET DSCP are packets that are coming from people who know what they're doing. And then in the network, all you have to do is look at DSCP and assign that to the right class of service. That is certainly a possibility. You don't always have to know which flow it is in order to give it the bounded latency zero congestion loss. There are other cases where you do have to look at it because you have to do per flow shaping. Depends on which technology you're using to achieve DETNET.
This is Stuart. I don't think we've got enough shared knowledge to take a meaningful decision, to be quite honest. I think we need to write down a focused document on this problem with some mapping to some applications, and then take the decision in the light of that.
The reason this is so complicated is that the idea of a DETNET flow is not the same at every hop through a network. It is entirely possible that this device looks at a number of things that had separate reservations made for them, but it lumps them all together and looks at any of these things count as this one DETNET flow as far as I'm concerned. Okay? So
Norm,
it's not
that goes to
necessarily
the-
true that every device has the same idea of whether two packets are in the same flow or a different flow.
Yeah, it's really important to capture that in the aggregation section of IP. We understand how to do aggregation very well in MPLS land. I think we understand it less well in IP space, and what you're saying is exactly right for that. So it's really important to capture that.
So I have a question, maybe mainly towards Tolas. So back to this iframe example of a video stream. If you want to have pref for the iframes only, but not for the rest, how do you do that with the 5-tuple only?
That's probably exactly a very good example to judge this model and basically say that's why we may want to have two different services there, right? I'm not quite sure what happens with the relative queuing order once you do that, but I mean those are all the good cases. I wasn't even saying that I don't necessarily like this, right? I'm saying there is just what I'm worried about is what TSV does, and what can we do to prevent what I would consider to be abuse, which is kind of DSCP based routing. Right, so the per node behavior, the per hop behavior, right, which is kind of to me EF, the elimination function, right? That's a per hop behavior. I think that's perfectly fine to do that.
But one important point to one of the commenters that maybe it's not every hop. We don't have to do it every hop. It's only the relay.
Oh no.
Nodes. So,
well, whether we need to do it every hop or at the end, I'm not quite sure what you folks want. I was just in the beer technology saying it's possible, right? But it gives higher resilience. No, but I mean, I think it's a per hop feature, the new elimination function. And so that's being new. We can also argue what we want to do for it. So that's a really good example. And I wasn't worried about the good ones. Just, how can we constrain the framework so that we can avoid the bad ones?
Lin Han from Huawei. I believe the best way is remove the DSCP, because to distinguish for different service, 5-tuple is enough. For example, if you can use a different port number for different service. And also, as another gentleman said, the DSCP is kind of independent. The PHP behavior, that's don't mix with the 5-tuples is better.
But how would you do then this example I wrote up?
For example, you can set up.
So the iframes need pref, but the rest not of the same.
That's a different story. What I mean is in the service level means that one flow is one service. You can distinguish by port number.
I missed the last two words, just the last two.
Port number. You can use a different port number to distinguish a service. You don't need to use a DSCP.
So you would want, let's say, the iframes on a different port.
Yeah, whatever. But that's a different, but because that's more complicated.
Right. One of the issues there is that I think the point that Torlis just made a moment ago is
because the DSCP, as the gentleman said, very likely checked early before the 5-tuple. Means that all DSCP value will go to same queue. They don't care about others.
So, Stuart, so can I suggest a way forward, because we're not moving very fast here. Norm says he's going to write, he's got a lot of material on this in a document he's going to publish. Why don't we wait till that document's out and then call a virtual interim call when we've got a bit more information and a bit more shared model, and then make a decision then?
Okay. Can I ask the chair to concisely state what we're arguing about?
Okay, we have three options on the table for flow identification of IP flows. Option one is that we use, I'll start with the one on the slide, where we classify flows based on the standard 5-tuple and the value of DSCP. So based on those values, which can be set as wildcard, meaning ignore, or bit mask, so say look at just these values, that maps to a single DETNET flow, which translates to a DETNET service. That's option one. Option two is we completely ignore DSCP. So any value that's there is ignored. So you only look at the 5-tuple flow. So if you have a 5-tuple flow with multiple DSCP values, doesn't matter, they all map to a single DETNET service. Thank you. The third option is we specify a specific value that must be present in any DETNET flow. So we use 5-tuple plus, let's say, 0. And behavior is undefined if it's not 0. Or we say that it's not part of the DETNET service at that point. That it's regular diffserv service. Those are the three options that I think we've talked about. Trollus wants to jump in and say that I'm wrong.
Okay.
So,
well, I'll deal with that when he gets to the mic. So I think that of those three that you mentioned, we're talking about a quality of service feature here. This is all about providing a certain quality of service. To ignore diffs, to require that we ignore DSCP is silly. Okay, I reject that one out of hand. Of the other two, I don't have a dog in the fight. I would be happy with either one. I think that there are use cases. I would look at what people are doing now with use cases. My belief is that today people do things with iframes and such that you use different DSCPs on the same exact stream. You use one stream to make sure they all take the same path and hopefully stay more or less in order, and you use DSCP to mark the important ones and the unimportant ones. I see no reason why we need to interfere with that convention. Okay? So I think so to me, the obvious one is make a DSCP one of the wildcardable fields.
okay.
So the model that I was thinking, number 4, is that you have the 5-tuple, and in the service definition of your flow, you basically have the per hop behavior definition of what DSCP within that flow means, right? Which is what we're doing today, which basically means that, yeah, so the DSCP cannot be used to define, the path behavior, like the routing stuff, but it of course can be defined, can be used to define the per hop behavior, which is basically that you are, obviously when there are multiple DSCPs in the DETNET flow, that these are going to be treated differently and preferentially in the way that these DSPPs are defined in RFCs today. If we want to change and add, DSCP behavior, that's fine. That's a typical, discussion in TSVWG then.
So to be clear, what you're saying is you'd like option 1 with a restriction that they must follow the same path.
Yeah.
So you want what's on the slide, but with a restriction that they have to be co-routed.
That's what I ultimately want, but I'm not sure if there are other implications about the DETNET service definition, right, that aren't appropriate for DSCP, right? DSCPs are for poor hop behavior, right? So obviously it's not the path behavior, but I'm not sure what else is in the overall DETNET flow definition that would also be inappropriate for DSCPs.
Actually, if we use DSCP to distinguish whether we need pref or not, that has path implication in the sense that you use 2 paths or 1 path.
If I can, I think we're confusing 2 things here, which is quality of service and routing. While it's true that there are people who just do mask and match on the front of the packet and do anything they want with the packet, and the fields mean absolutely nothing. Okay, to me that's the SDN model. Okay, that can be good or bad, and I'm not going to argue with that. Okay, but within DETNET, I don't think our intention is to define a new way of doing routing. Okay, I think we want to be, it's a toolbox. We want to be compatible with stuff. So there are different reasons to look and identify the flow. One reason you look at the flow is to route it. One reason you look at the flow is to assign it to the right queue. Okay, let's distinguish those 2 purposes. Turles seems to be really worried that we're going to route based on DSCP. Okay.
Oh, you gotta be kidding. We just lost our Etherpad.
I don't want to rule that out right now.
So,
okay, because in order to get you the service, I may have to pass you down through a nailed down path. Okay, I may have to pass through a nailed down path, and that's complicates things.
So can I make a proposal to make the next step from here to, for now, for the documentation, next revision of the documentation, to keep it as is on the slide, 6 tuple with DSCP, and on the way as we go on, if we figure out how to scope down, or if we need to scope down and so on, we figure out on the way.
Thank you. Yeah. And I think what we document should capture the intent of 5 tuple is on path selection.
Yeah.
And DSCP is more about per hop behavior, which really translates to queuing. Yeah. Traffic treatment. It translates to local traffic treatment. All right. So Torles said off mic is that he would like to, he thinks it's great to see pref as an example of why you might want to do this.
Yeah.
Okay. So I'd like to, I think, did we finish simplified or you have more points?
This is what I wanted to ask.
Yeah, I think we just finished simplified. So I'd like to note that I think we've accomplished our main goals for this meeting. And boy,
in time,
we did it like on schedule, because we said we wanted to do that by 1:30 among our privately. We didn't say that to everyone, but that was our internal goal. So I think that's a great accomplishment, even with the fact that we have 2 major open issues here. One major open issue is on Mpls. Hopefully someone's capturing notes here.
Yeah, yes, you can head back up.
Okay, great. One major issue we have to check is with the Mpls working group. We have a major change there, I think actually more major than in TSV, that we want to use control word on L3 VPNs. That's not anything that's done today. And we're proposing that we will always do that so that we can support both the pref and non-pref cases seamlessly. Can I have a show of hands of folks who think I got that wrong? Wrong. Because I was going to ask you to go to the mic. So I note that that's no one. Now I'll say, how many people think I have that characterization right? It's a few people. I was hoping for like at least half the room. It wasn't half the room, but it was a few people, and those. Okay. So, Norm, you can put your hand down. Or.
So, Laura Anderson, I just wanted to explain why I didn't raise my hand. Without the Mpls chair hat, I would have raised the hand. But since you say you're going to talk to us, I want to be take that decision without further prior commitments to going into that discussion.
Okay, I actually appreciate that because I did happen to notice what you did there, and frankly, is part of the reason why I asked for objections first. So that was item 1. For item 2, I think our main discussion has been on what's going on in the host, not in the middle of the network, and that we are saying that the I think it's, do you have 6 tuple listed? Yeah, you do. That we're going to go down a path of 6 tuple, but with the qualification that 5 tuple is used for path selection and DSCP is only used to differentiate local queuing behavior and reliability delivery. How many people object or disagree with that statement? Again, I see none. That itself is an accomplishment. Thank you. How many agree with the statement? Interestingly, it's slightly more than who agreed with the MPLS statement, which I thought was really non-contentious. Although I do note that it is a bigger change. It actually is a bigger change in terms of what's done on the wire, what we agreed to there. While we all agree in this room that a control word is a good thing to have consistently, it is a big change to L3 VPN, and we should note that.
So Pascal, the reason why I did not raise my hand this time is I'm still concerned with Norm's point about the nailed down path. Basically,
I'm actually not hearing you here. It's on, it's just you have to speak up a little.
Okay, so the reason why I did not raise my hand this time is that I'm still concerned with Norm's point about the nailed down path. It seems that the way you worded it, if we nail down a path for a DETNET flow, all the rest of the flow has to follow this same path. And I'm not sure we can say that. We may have tunnels, we may have circuits, and we may inject data in that circuit. It's a per hop behavior, just put that in this circuit. But we may have to do that, and this circuit may be following a path which is designed, controlled by a controller somewhere. Whereas the normal flow will follow the IP routing, it's going to be a different thing. So it's not really a routing decision, it's an encapsulation decision, if you like. But I want to make this distinction, because otherwise we seem to imply that everything has to go over the same path of the tunnel.
Okay. I think it'd be really good to make sure that the notes accurately reflect what you said, because I'm not sure I fully got it.
Yeah, I don't think the Etherpad reflects that well, and I'm not sure how to summarize it. So if you could, if you're on Etherpad, if you could just make sure it's put in there. Or I guess if you don't want to do that, send it to the list. So
if you just leave the Etherpad open an hour after the meeting, I will fix that. But if you capture the minutes right after the meeting, then no, I can't, because if I have my laptop, I read it during the meeting, so I took this rule as
maybe just restate it again, or restate it differently. Exactly.
Okay, so I tried to say that it might be that the DETNET service is a certain path which is nailed down by a controller, which has, and it's kind of a circuit, and it has nothing to do with the path from A to B that a packet following IP routing would follow. And in that sense, when we take a packet, we look at the diffserv flow in there, and we figure that it's a DETNET flow. We put it in that circuit, which is some encapsulation, and it goes over a certain path. And if it's not determined as a DetNet packet, then we leave IP do the routing for it. It's going to go over a different path, which is not under the control of the controller. And the result is those two packets for the same flow will not follow the same path. And I think it's very important that we can do that. So we can call it a per hop behavior, and I'm happy with it because it's just the decision of encapsulating or not encapsulating in this node. After that, the routing will do its thing, but on the encapsulation. But still, the packets will follow different paths.
Right. So to make sure I heard your point right, and everyone else agrees, you're saying that there are cases where you think that it's okay for different DSCP values within the same flow to follow different paths.
Yes, because one of them gets encapsulated and the path is determined by the encapsulation, not by the encapsulated packet.
Okay. So the document will start out talking about that 5-tuple is used to select path. I think it'll be really important to bring in this case you're thinking of and make sure it's adequately covered. My expectation is you should object to the first version of the document.
So, so far I haven't heard, an example that would really make me say, oh, I like this. So like your example for the EF, which is kind of new per hop behavior, that was a good example of what we're doing, usefully better, right? So the example I heard from Pascal was more like, okay, so you still can't guarantee that, the same or different DSCPs of the same DetNet flow will flow across the same path if it's kind of not in our control, but an underlying service, right? I think that is true, but whatever we can't control, right? So that's not an argument to say it's a good thing. So it would be good to have an example of a good thing. We're saying, okay, the same 5-tuple, 2 different code points, here's a good DetNet reason why they should be routable across different paths, right? Because if once we have a TSV argument, then I think that good really example that would persuade them might even say, okay, fine, then maybe we haven't done it in the past, right? And we have felt it was a bad thing to do in the past, but with these use cases. Yeah.
Pascal, again, I don't like the terminology of saying they are routed over different paths, because once the packet is on the DetNet ingress, the packet is encapsulated. The inner packet is not routed anymore. It's just following the encapsulation. So there is no per hop routing decision along that path. It's just the initial encapsulation on the DetNet ingress, which happens or does not happen. If the ingress encapsulation happens, then whatever you put as the outer header will determine what happens on this packet. And it won't be routed because of the SCP. It will be routed because of the encapsulation. It's just the decision of encapsulating or not at the ingress of the DetNet network which decides whether you encaps or not. And then routing is routing.
Pascal, this is Padma Moray. There's something that actually part of your discussion made me think, how does this work with ECMP? Because what you're saying is, I'm not understanding how we're going to make this work if you have ECMP.
So can I suggest
because then you're really having... So that's why when you mix all this together, it becomes much more complex.
Can I suggest to continue this discussion on the list, because I'm afraid we cannot make any step further. Like we will see text in the document, it will make easier, and we should definitely continue all these aspects being discussed on the list, just to be able to progress with the wrap-up and the rest.
Do you want to talk about this slide? Because sorry, one more conclusion from the group is that we can provide DetNet service over IP in the middle of the network as a case of MPLS over IP, using building on the standard techniques for running MPLS over IP that already exist as RFCs. And I think that should cover what Andy was saying. So this is not really native IP support. What it is our MPLS mechanisms our MPLS mechanisms, including pref, over an IP PSN. Okay, does anyone object to that? No, good. No one. Who agrees with that statement? Basically, Andy. No, we got a few more people. Okay. So that's the smallest of the polls, but still a reasonable number. So with that, there was one other important part in your deck. Say again?
I would like to hand over that to you.
For this one?
Yeah?
Oh, okay, sure. So there's a bunch of other topics. Sorry. There are a bunch of other topics that I don't think it makes sense to, or we didn't think we'd get to today, and it looks like we don't have a lot of time to dive deep in these. That is if we want to still do the other material that we've talked about. And it would be very good if we could get some text contributed on this. Stuart has done a really nice job on the with some starting text. I'm not saying it's finished, but it's still a nice start on aggregates for MPLS, for example. It'd be great if we also got, I forgot who described what happens in IP networks. Norm described in what happens in IP networks, and we really good to get that text captured and sent to the authors or sent to the list and get that into the document as well. We have lots of other areas where we're going to have to work through the details of these. And you want to switch to the wrap up? Yes.
I think we're going to have some regular interims to sort of virtual interims to make sure that we keep up some velocity on this.
So that's exactly where I wanted to go on the wrap up slide, and why I wanted to switch to it. Just give me 1 second. Sorry, I thought we had it queued up on a different laptop. Come on. So certainly we need to go, so where do we go from here? Certainly we need to capture the results of this discussion, and some of which is already there, but we certainly need to get the full piece. And the question is who should do those pieces? We have good text that's there that it needs to be split. We've talked about a document split multiple times. We've delayed it. My view, and I'd like confirmation from the working group, my view is we should do the next version should be split, where one part is MPLS, one part is IP. If we want to do more splits down the road, we can do more splits, but initially we should take the existing document, split it into two, publish that, and not have a, 0.5 version of the data plane solution. Does anyone object to that?
Lou Anderson, I think I agree, but then you're not clear. So
sorry, it's been a long day.
I think we should split in the two pieces you talked about. But at least on the MPLS side, I think we have good text from Stuart that we actually can put into. So you could merge.
I'll get there.
Okay.
I want to make. I will get to what we do with other text.
Okay. I would like to work on the split version in whatever method you decide to make it split on the MPLS part of the split version.
I was going to say, I heard from both authors say that both sets of authors, that they want to work together. So
yes.
Will you work together?
Yes.
Awesome. So, and more than that, even if you don't work with them, your document is published and they have every right to take whatever they want from it and include in their split document.
I think the sanest world will be if we found a way of working together.
Right. So I think it would be wonderful if during that split that the authors of the current working group document and the authors of the other two documents work with the author team on that split and participate in it.
Yes, I didn't have time to do it before, but I think absolutely the people who wrote the original text should be part of the team that construct the new derivative text.
Yep.
I'll also be glad to help in any way I can.
Great. And this should be worked at the author's level without any chair interaction is our hope.
So the only thing I'm not clear about now is, are we going to post one draft that is just a split, or can we actually put the new text into that as part of the work on splitting and merging?
So the split should, the next version published should be A, split, and B, capture as much as possible of the results of today.
Yes, and I think for cleanliness, we should call it something completely different. Not the old name, not the new name, with the people who've worked on the text. Call it something else. By the time we next meet, we will have a brand new document that.
So let's have a DP sol-MPLS and a DP sol-IP.
Yes.
Let's go.
It should probably be.
I'm not telling you how to title it. I'm telling you what the file name is. The file name is DP sol-MPLS and DP sol-IP.
Okay. All right.
And we're assuming that those will start out as working group documents, not as individual documents. And that is based on the assumption that people can work together. Good. All right, those I think are the most important pieces. The last thing I'd say on the document is if you are present here and haven't written anything on any documents, you too can contribute. So it would be, if you feel like writing, take the initiative, write up what you want to write, send it to the authors, send it to the list, do both. That's great. It's a great way to be involved in the process, and make sure that if you have a particular issue that you care about, that it is captured in a way that you think is accurate. Okay. The last topic is we want to be able to move to continue working at a higher pace. And we think that is really important to try to get through that list of issues, and was the reason why we wanted to make sure that list of issues was shown before jumping to this slide. How do we want to do that as a working group? Some of those may be appropriate to call an interim on. Some of them may be just working through the issue. We don't have to have an interim in order to make progress on a document. Other working groups have made great strides and great progress on very complex work by holding regular meetings that are advertised to the working group and anyone can attend, and that there's notes that are sent to the list. Those are not formal interims. They're informal working meetings, very focused on specific technical issues that everyone can participate in, and everyone can see what the results are in the minutes. We're not saying that we have to do one or the other, but we want to suggest that if the people involved who want to work on this at a faster pace, they can self-organize and do those things. And we do have resources available. We can give access to the DETNet WebEx if there's not a WebEx available. There's pluses and minuses with the IETF WebEx, right? Including limited dial-in numbers, so sometimes that's not the best thing. But we'd like to consider this. One comment we'll make is the frequency frequency can be self-determined, weekly, bi-weekly. Openness, you definitely if you're going to do this, it's important, or if we're going to do this, it's important that the invite be open to all and that the reporting is to all. One thing is keep conscious of what time you meet, because by selecting a particular time it's fixed, you might be placing an undue hardship on someone who's in a very different time zone. So if you do this, perhaps think about shifting time zones.
And since the WebEx details have to go out in the public list, remember the precaution that we were given the other day about making sure you shut it down afterwards, because people have been hijacking them.
Yeah, if you weren't aware of it, if you see random attendees who don't turn on their voice, that means they're trying to hijack you. And I have definitely seen that. We also wanted to raise the prospect of a physical interim. We tried to have a physical interim with 802 co-scheduled, co-located, thank you, with 802, and it failed because we couldn't get critical mass. Do we want to start thinking about a physical interim?
Just for completeness, the three of us have run an exercise on checking a possibility of co-locating again with 802 in May, but it's too many holidays around, US holiday and so on, and it seems it's not feasible.
In May?
In May.
I'm glad it's not feasible in May because I couldn't do May either. But I do think that the amount of progress we've made today sort of suggests that getting together is a very valuable thing to do. But that should be in addition to virtuals.
Thomas, I mean, did you try to make roll calls how people felt about the virtuals? I thought they were similarly effective. I mean, this is a lot nicer, but yeah, with, you know, all these continents and airplanes, it came at a cost.
Yeah. We do recognize that budgets are a major issue with, and want to be sensitive to that. And that's part of the reason for asking for input here. Yoni?
Yeah, just voice my opinion. So I would avoid the physical interims just because they are just hard to justify to go somewhere for a day or two. But the progress today, in my opinion, is mainly because it was well prepared. People put a lot of effort to prepare things in advance, and we can achieve the same in any interim if we put the same effort of preparation. Just
okay. I think maybe the next step then is, rather than trying to schedule a physical, which would be nice, but I don't think we got overwhelming support for here, is that we schedule an interim as soon as we have the document published. And I should have said one of the documents published. It's perfectly fine if the split that, well, let's say we get the Mpls document first, or it's probably the Mpls first because the text is a little more mature there. We can start the interim there. And then once we have the interim on that document, we can shift more to a working mode of working through those more detailed issues. Yeah, please check for blue sheets.
So I kind of understand who's on the MPLS writing team. Who's on the IP writing team?
The default is all the current authors.
Yes.
And we have two documents, one that's focused on IP and one that's focused on MPLS.
So,
I think that complete set figures it out.
Okay, fine.
And then in addition to that is, if we start getting contribution from other people,
absolutely,
they get to participate too.
Delighted for it.
And I appreciate the authors that have been working this for a long time, notably Yodi, and to herd the cats.
So I have one other bookkeeping issue. When we start doing the informal meetings among a group of co-authors.
Well, no, it's interested parties. It's whoever wants to show up.
When we start doing meeting with interested parties, we actually need to make sure that the working group mailing list gets some type of report on that. I have had a couple of problems on the MPLS side where people go off and have a couple of meetings and then they come back with two-line report summarizing like 3 or 4 meetings. That doesn't work. We need to actually make sure that we report each and every meeting, each and everything we want to change to the mailing list.
I 100% agree, and I apologize for not saying it. I thought I meant to say it.
You didn't say anything else. I'm just kind of creating a mindset that we actually do it.
Absolutely. I mean, to me, that's part of openness and consensus building. Yeah.
No, you said briefly that it has to be reported on the list, but it's good to put emphasis on it.
All right, with that, we'd like to know if there's any other comments that anyone would like to make related to data plane solution, because we're about to move off data plane solution into the other two talks.
Just have a very old question. I don't know if DETNET want to talk about control plane.
One more time.
Control plane.
So right now, control plane.
I know the charter doesn't include it.
Right now, our deliverables do not include control plane.
Yeah.
We are, from my perspective, and if you look at the milestones, we're behind on our deliverables. So we really can't talk about expanding deliverables at this point. Once we have some very good, a little bit more progress to the point where we're close to publishing, or we're starting to wrap up that work, it would be fine to be talking about how we deal with the control plane. So if we're lucky, maybe we can start having more serious discussions on control plane in 103, but that's assuming things really come together between now and 102. So we'll have to see. The other thing is certainly control plane requirements is something that's appropriate for us to be talking about. We wouldn't want to be getting deep into extensions in other working groups protocols. Those really should go over to those working groups. So we have to be careful about when we start talking about control plane to make sure to keep in mind that we're not the owners of those protocols. So it's fine to talk about it here. The requirements are important to talk about here, but the actual extensions go into the working group that owns those protocols. Does that answer the question? Other comments? All right. Well, that's great that we accomplished our number 1 and number 2.
Okay, thank you. So we can move on. We have 2 more presentations for the next half hour.
You have another USB?
So, Stuart, please.
Okay.
So you can have the control. Yeah.
So I'll put some sort of some silent background in front of it.
Still need to eat this.
I'll put some silent background in front of it because everyone asked the question. The reason that we're doing this is inspired by the need to have an underpin for net slicing. We didn't want to get involved in all the politics and all the strangenesses and the huge issue of net slicing. What we wanted to do was to find the underpin that would allow someone to build it, noting that that same technology is useful for other things as well. For example, you could integrate this, and we'll show you that you need to do that, with deterministic networking just in its own right, with some completely different application. Well, I kind of ignore this one because it just sort of says that we've been writing this for a while. We've been working on this for a while. And we've been working on it in the R2GWG area. And I think we've had some discussions with Lou, and this will continue now in the T's area.
And to be clear, that was in conversation also with the AD who owns the working group. It wasn't like I just said it.
No. I'm absolutely fine to have a willing home for this. So this is what we're doing. There are a number of enhanced data planes that people are designing, mainly, as I say, influenced by the big influence is 5G net slicing, but there are other reasons for wanting to do it. So we have an enhanced data plane. It might be a FlexE data plane, it might be a TSN data plane, it might be a DETNet data plane, or it might just be simple complex queue management stuff. And what we want to do is create a VPN for use by a particular tenant, and in order to give them the enhanced service they want, we need to map their VPN onto some dedicated resources in the underlay. So the big thing that we're doing differently here is the integration of underlay and overlay. There are a number of ways we may do this. One of those ways is with segment routing, but that is not the only way that we might do it. On top of that, we have a control and management system, which we note has to be have some scalability properties, but that's not where the focus of our work is. So this is what we sort of see. The thing that that differentiates this is the need to provide isolation between the different tenants. That is to say, the tenants shouldn't realize that other users are anywhere on their network. If we look at what happens in networks at the moment, normally we have statistical multiplex ordinary VPNs. People who want absolute isolation, we could build that for them, but essentially what we'll be building is an isolated independent network, and that's expensive. So what we're trying to do is to have a safe flight. What we're trying to do is have a pragmatic solution, kind of the same philosophy that we had in pseudo wires. If you want a real one, buy a real one, but we can probably do you a cheaper deal if you share on the same network as everyone else, and it should be good enough. So we're looking for this sort of pragmatic approach in the middle. Performance. So at the moment, VPNs are largely best effort. We can do a short bandwidth, but we are concerned about whether they scale to the number of tenants that are needed. What we don't have is guaranteed latency and enhanced delivery, which is what you're working on here. And so we see the work that's going on in DETNET as a really important underpin for this VPN plus work. So in order to do that, you have to have a mapping of resource to the VPN, to the particular packet that's going through. Those things might be virtual links, there might be dedicated queues, etc. We have a draft that was being discussed right now in spring, or has just been discussed in spring, that describes some of that, and we'll probably have a draft in LSR next time. We were worried about scaling. Scaling is a problem because fundamentally, if every flow or every service has to have its own dedicated resources at every hop, then you kind of need to have one label per service per hop. We suspect that actually some services will require dedicated resource at each hop. Some will be able to share, and some will need a mix depending on the service capability of the underpin. And that's why the aggregation stuff we've been talking about is important. We can ignore this. It's going to go into T's is the agreement that we've got. And that's the end of it. There was probably a bit more discussed in RTGWG. I probably gabbled this a bit. If you go and listen to the recording, you'll have a more measured approach. Okay, so thank you, feedback, contributions particularly welcome.
Thank you, Stuart, for moving that along pretty quickly.
That was quick, yeah.
Yes. Yes.
It is.
Well, I think probably some of us saw it earlier this week as well. So, yeah. I think it's great. Thanks.
Send it. Listen to the other recordings. Send email. Whatever I can do to help you understand it.
You don't have the links to the drafts here, but I guess people can find it. Or do you want to send an email to the DETNET list with the?
Yes, I'll send you a link to the DETNET. I can't even remember what the name of the draft is.
Yeah, sure. Email is better.
Yes. I'll send you some pointers to the list when I get back home.
So any comments, questions? Okay, then let's go to the second presentation of this half-hour slot. Yeah, so this is the mic for you. Yes, please.
And I will introduce. Does it work? Okay, does it work now? Okay. I will introduce our work about the IGPT extensions for DETNET information. This part of work is just, I think, help to understand the work of the YAM model. And
Can you please stay in the, just for the video?
Okay. Just help to understand the work of the topology YAM model. And as we all know, in the current IETF work, we always use IGP to collect topology information. So we want to do this part of work to complete it. And this page we have already showed in the DETNET configuration YAM model. That means all the attribute we defined in the IGP extensions goes along with the DETNET YAM model. And part of the attribute has already been defined in the draft, and part of the attributes is waiting to be ended. Now we do the OSPF extension for DETNET, including 4 sub-TLVs to link TLV. There are congestion control method sub-TLV, maximum DETNET reservable bandwidth sub-TLV, available DETNET bandwidth sub-TLV, minimum and maximum queuing delay sub-TLV. And I think all these TLVs has already been its corresponding attribute has already been discussed in the last session. So it's just some encapsulation considerations. And next steps, we have already declared that it goes along with the topology data model, and we ask for more comments from the working group. And we will improve the document based on the feedback. And actually, this work is not in the current charter because Lou has already said that the control plan protocol is not in the current charter. But it is a good supplementation to the DETNET configuration YAM model. So perhaps how to process this document is another question to be solved. Okay.
Yes, Greg Mirsky, could you please roll back one slide?
Okay.
And one more. And where you have very good slide that captures list of all parameters that you extend, all the metrics. Yeah.
Sorry, this slide?
No, before that.
This one?
And one more before. And back. Yes, this one.
I don't know why. This one, right?
Yes,
Okay.
this one. So again, I'm very interested in what Norm presented, and again, I want to bring this residence time. So again, there are some limitation of the metrics that currently being advertised in TE extensions that exclude queuing delays. Yes. And when we propose new metrics, we need to think at the same time how this can be measured. Because if metrics cannot be measured reliably, I don't see it very useful.
Actually, I have already said that I think this part attribute is not for measurement. It is for calculation, computation, because as Norm has already showed about the bounded latency mechanisms, the bounded latency is guaranteed by the queuing management algorithm, and depends on all of these algorithms, we can do the calculation about the queuing delay. And there is no need for measurement now in the DETNET scope.
Again, we can discuss it because I think that DETNET application services will have different requirements towards guarantee. Yes. So thus, there might be some services that give you, that can use multiplex over subscription. And then your parameters will be different. So again, there will be necessary, and I don't see that only installing without feedback based on performance measurement is a practical solution, because only configuring something and not being able to verify through active or hybrid measurement method, I think it possibly creates a black box. So when we think that we can configure something, we need to think about how can we verify that in a network, whether it's activation testing or live service.
I hear my name being used. This is Norm Finn. I think you're both right. In creating flows and so on does not depend on measuring how the network is being used now and responding to that. But certainly a user of the system may want to verify that it is actually giving him the service that he wants.
Good comment.
And when, not if, but when something gets screwed up and you're not delivering the service that you want, you want to find out why. So, you're both right. It's not necessarily a part of making the reservation, but there's got to be some way to verify that it works.
Yeah, I agree.
And as I understand, these parameters are the ones that a node advertises of itself in an IGP. Of course, it should be not false, so it should be a real value, and we need to be able to verify. I want to mention again this RFC 7813, which provides ISIS extension, similar thinking, similar aspects like available bandwidth, making bandwidth reservation, simple ones on a graph.
Yes.
I'm not saying it covers everything needed here. I'm just pointing on it. That has been a similar approach a couple of years back already, and that is used in bridge networks today. So if you want to be online, it is good to take a look. A question: do we need? So this says maximum DETNET reservable bandwidth and available DETNET bandwidth. Like, why we specify DETNET? Like, you really want to dedicate by configuration to some bandwidth to DETNET? Because in certain, it can be a simpler approach to say that, oh, this is the total available bandwidth, and this is what we can use. So you distinguish DETNET and non-DETNET bandwidth, as I understand.
I'd say this doing OSPF extensions for DETNET is reasonable when we have the model reasonably solid. Our Yang models and so on are reasonably solid. We know what the parameters are. I think that we may not know all the parameters right now for if you're going to do one particular flow. If you're going to use OSPF to create, is your plan to use OSPF to create a reservation for a flow?
Oh, no.
Oh, okay.
It's totally different.
This is just to distribute information about the network.
Yes.
Yeah.
Okay. Well, then I'll just say that something like the max DETNET reservable bandwidth, I assume that would be per link, or maybe it's a percentage.
Yes.
Yeah. And that's essential. Yeah, sure. Available DETNET bandwidth.
Actually, the maximum DETNET reservable bandwidth is the whole bandwidth can be used by DETNET, and available DETNET bandwidth is the unused part, and it can still be used by new DETNET flows. So these parameters just
so that would be dynamic then.
Yeah. The second is dynamic.
Yeah.
The available is
dynamic. It will change when new DETNET flows joins in the.
Okay, and what's min-max queuing delay?
Yeah, the queuing delay, I think, is.
What is that? The min-max queuing delay?
You mean will it influence?
What does it mean?
What?
Your your last bullet,
Uh,
min-max queuing delay.
uh-huh.
What is that?
I think it is the based on the queuing algorithm, and we can compute the queuing delay, the maximum and the minimum for a link for output queuing.
For a hop, for one hop?
I think it's for output port.
Per port.
Yeah.
Oh, so that's the time it takes to get through that node?
Yeah, I think just the packet goes through the device and in the egress, and there is an output queuing,
Okay.
right? And the queuing will deploy
Okay.
the DETNET queuing algorithms.
Okay, then.
And so the queuing delay can be calculated. That's the point.
Then I would suggest, and I apologize that it's taken so long to get the bounded latency draft started, but I think that will, that parameter would change, I think, as a result of the bounded latency.
Do you think all the algorithms will influence the value of this parameter? I think part of the queuing
No,
algorithms.
my point is
Yeah.
that Jean-Yves Le Boudec gave his talk in Singapore, and looking at his book and talking to him further, saying that, if I understand what that is, obtaining the worst case end-to-end delay by adding the worst case delay at each hop
I get
is
your
not the right
point.
way to do the calculation.
Yeah, I get your point. That is the
That's
part
all.
of the network calculus, right?
Yeah.
Yeah, but I think it's a little different in determinist networking, because it is guaranteed by the queuing algorithm, not the calculus, right?
Well, no, because the worst case delay at one hop depends on what's been going on in the previous hop.
Yeah.
Okay?
Yeah.
So you simply cannot sum up the delay at each. No, you can, but then you get an answer which is much worse than the actual worst case delay. So you'll get an answer that says the worst case is 18 microseconds, and my flow needs 16 microseconds, but the real maximum is 15.
Yeah, I get your
So
point. Yeah.
you know, I would be okay. So yeah, so I'm just saying
But I think
that this may be a great idea, but I think you maybe need to wait until we settle on what the parameters are.
Yeah, I totally agree about the bounded latency draft will influence this part of definition, and it is always open to discussion. But a little comment about your response is that I think that is the way of calculating the end-to-end latency, right? Perhaps we cannot just one per hop plus how to say it? Just one per hop latency plus another per hop latency, perhaps plus another per hop latency, and it is not the answer of the end-to-end latency. Perhaps, right?
Okay. Again, I support Norm's, if I may use his name again, and not call him to the mic. I would. It's discussion. It's a very good and healthy discussion, and useful and great that we have this discussion here and face to face.
Yes.
What I want to say is, take a look at some documents, and actually, I can take on looking and sending to the list more specific references to documents in IPPM working group, because it's not necessarily the min and max are useful metrics. Maybe not minimum and maximum, but mean parameters might be more useful.
Not here.
No?
Not here. We
Okay.
are.
Here we have, or at least might be percentile. But at least what I want to say is keep it open.
Yeah,
As Norm points out, in this room, we are after the bound. We are after the worst case, not probabilistic stuff.
Is this meant to enable, you know, RSVP, CSPF like calculation of path and calculation of resources?
Perhaps we just extend the collection part, not the calculation part. if I get your question right.
Right, but I mean, so then the answer is it's purely for OEM. It's not for path calculation.
Yes, I think so. It's not for path calculation. I think DETNET perhaps have other considerations for path calculation, and we just do the extension to collect the topology and the capability of the network.
Yeah, and that, right, okay. No, right. If you had said path calculation would be totally different. But so are there any
Perhaps different, perhaps not, but it's not the scope.
well,
of
you
this
said no, so I'm not going to make that argument. What I would have expected then. But so let's say this for the OEM part, I have no good background of prior art where, you know, you would flood this OEM only information into the IGP, because I always thought that they are not so happy to have a lot of, you know, be abused for flooding for anything that's not involved in path calculation. So is there prior evidence that we have that?
Your point is correct. That's my understanding as well. So,
I mean, I love to abuse IGPs. We just need
so
to.
but actually, these type of parameters, available bandwidth and so on, are for path calculations in classic IGPs.
Exactly. Yes, but that's why I was asking, because if we go back to the use case of the path calculation and the resource reservation, then I think that would all be subject even more to, you know, these classifications of different mechanisms from norms QS draft, because you know, I mean, there may be calculations that depend on knowing exactly every individual other flow that was allocated, which is a lot different from what you've needed in the much more lightweight in-serve service model that RSVP does, right?
Yes, I think it perhaps related to this page about the queuing management algorithm. I think just as you have commented, the different queuing algorithms and the queues mechanisms will influence the attribute. Exactly. It will.
So, you know, I mean, I just think it's somewhat premature right now to try to already get into all these, you know, attributes, rather than, I think, looking at the framework, right? What is it that and maybe even, you know, this should go to T's. I'm still trying to figure that out myself, what to do where best. And unfortunately, I think we just lost the T's chair to an airplane or something.
Yeah. Yes, and the T's chair is not here.
Yeah. So, right, in terms of, you know, what are we trying to do with the IGP, right? And what type of information would we need? What amount of communication is needed, right? I think the parameters in the end, once everything is settled, that's the least amount of problems, right? But just high level trying to classifications of what would be done, what type of information is needed. I think that would be, highly useful as a starting point when we get into the control plane, so that we understand what dynamics we will have.
Yes, and I think it's a good suggestion for just not only this IGP extension, but also the YAM model configuration. Configuration YAM model should cooperate with the bounded latency draft and try to define the parameters needed in the node.
Yes, definitely. Yeah. So this.
Okay, do I need to announce myself? I think that Turnus makes an excellent point, because if all the model for the DETNET, it's a centralized controller, not distributed system, then we don't need IGP extensions.
You never know. I mean, you can have an approach when the centralized controller collects all the data from IGP. So there are hybrid approaches. It's there out on the field.
Okay, because if somebody wants it, then of course that's valid. Otherwise, we need only LS extension, BGP extensions.
So, I mean, there are all type of ways to cut the cake, right? So for the BRTE framework and T's, which you may want to take a look at, which isn't really trying to get into these QS things, right? Because I wouldn't have figured out, but I was trying to come up with a data model, right, that we can use through Yang, or that could be flooded in the IGP, so that in the end, you can build yourself the network solution you want, everything only from the PCECC, and or just, you know, I mean, maybe there's something about that. I haven't really thought about all these QS things for DETNET in the context of such a framework, but I'm saying maybe starting with the framework might be an easier step, as opposed to random details on the bottom of the queue.
Pascal Thubert. I respectfully disagree with Greg. I mean, we have written clearly in the architecture that there is a need for having a network which can support both deterministic and non-deterministic flows at the same time. I think it's a key design point. And thinking about the IP and caps, if we are using IP, I expect there is an IP network doing whatever routing is in place there. And that there is a controller someplace which will establish some circuits or whatever we call them, using IP over IP and then the sequence counter in the desktop and everything we defined. And that's kind of an exception rule for those DETNET flow that we isolate based on the 6-tuple or whatever. But for the mainstream packets, it's still going to be IP and IGP. So I disagree with you. I don't see that. Well, some people may do it, but the general case, I don't expect it to be a DETNET-only network. I think it's a shared infrastructure, and DETNET being some of those flows controlled by the controller, but the whole background traffic would be still normal IP. At least that's how I see it. It's just my vision of this.
Okay. Yeah. Yes, there are many ways to do it. I think you have got quite enough food for thought, like on what steps or what investigations make as next step. But ultimately, we need to do the basic work first, as many people point out, before going into control plane details. So thank you for the presentation. And we have 5 minutes left to wrap up. Any other topic to discuss before we close? I think
we're wrapped up then.
Okay, then thank you very much for staying this long, and thank you very much for this efficient session. It was very good. Thank you, and pay attention to the email list. There will be further virtual meetings coming up, working meetings, and maybe interim. Thank you. Okay.